Hi, welcome to the pre-calculus lecture series. And in this video, we're going to talk about section 4.5, exponential and logarithmic equations. And this will be our last topic in this section about exponential and logarithm functions here. So in this video, we're going to talk about how to solve the exponential or the logarithm equations here. Okay, so let's go ahead and start and let's go to the lecture notes and let's take a look here. Okay, so the first, let's take a look at what do we mean exponential equations here, okay? So we talk about, we say exponential equation excuse me. Okay, so it's one in which the variable occurs in the exponents. This is how do we distinguish the, like this is, we call this exponential functions, right? So we distinguish because the, the variables is the exponents. This is how do we distinguish those with x to the 8th power. This is power functions, right? So that's what's the differences here. So now in here we said that, if exponential function, if I have ax equal to ay, if both of them, look here, they have the same base and they are equal, then yes, we can conclude x equal to y because it's a base equal, then the exponents has to be equal. So let's take a look based on this the basic idea. So we say the first one's here, we say 5 to the x equal to 125. So I know the 125 is a 5 to the how many power? Third powers, right? And then now you see, hey, both of them have the, the base equal to 5. So what is the x value? Kind of you can just cross out. So what is x value? X equal to 3, right? Okay, so the same way is here, like if you see 5 to 2x equal to the 5, the x plus 1. Oh, they have the same bases here. And you say, okay, that's good. I can cross that out. So what I have here, and my exponents here will be 2x equal to the x plus 1. Then you minus x, both sides, you will get x equal to what? X equal to 1 is here. All right, so for those type of problems, it's pretty easy to solve. But how about, if my exponential equations is not that easy? So then what I need to do, see here. So here, okay, we have some general guideline, and then I'm going to kind of use example number 2 to show you the guidelines here. So the step number 1, they said, hey, try to solve it. If it's not like that easy, how do I do? They said, isolate, isolate the exponential expression on one side of the equation. Okay, so like in here, so for this problem here, we say, hey, let's try to solve the 3x plus 2 equal to 7. Okay, so for this problem here, they already, the one with the exponential expression, like this one is already on the one side. Okay, so that's good. We don't need to do anything else. Okay, so then the number 2 here, let's say, in order to do that, like take the logarithm on both sides. Then apply the laws of log to bring down the exponent. Okay, so what's that means here? So let's say take the log. So in here, you can take any type of the log. Of course, you can take the common log or natural log or any other log. That'd be fine. But in here, of course, let's try to be easy. Let's take the log 3. This is x plus 2. So I'm taking the common log, right? So it's log what? Log 7. So I'm taking the log function on both sides. And I do not have the base. That means this is a common log. And then we know by the law of log, if you have exponents, then what do you do? See here. So that means, you can bring the exponents down, right? So you can say this is x plus 2. Then here, this is log 3 and equal to log what? Log 7 here, correct? All right. Then we say, okay, then with number 3 here is what? We said, after you do that, then let's just like the algebra, let's solve for what? Solve for variable. That means to solve for the x here. So now I need to solve for x. First thing is I can divide it by log 3, both sides here, okay? So after you divide it by log 3, so this is x plus 2 is equal to what? This is equal to the log 7. Oh, shoot. Okay, so so this one's here. Okay, so after, well, I thought I erased it. I guess I did not. Okay, do a good job erasing. All right, oh, it's come back again. I don't know why. Okay, so this is a log 7 divided by log 3, right? Okay, so now you can minus 2 both sides. So you're minus 2 both sides. So I can find that the x is equal to the log 7 over log 3 divided by 2. Like when the problem, when the problem, they say, find the exact solution, okay? So when they say find the exact solution, that means they want you to leave the answer in the form. So the x is equal to the log 7, log 3. And then the second part, they say, hey, put this into a calculator and get an approximation. So you can use your calculator, put log 7, then log 3, and minus 2. So then you can say here, the second part here, so by calculator, you just plug the log function in, right? So be careful. If you use log here, then you use log, or you can use the natural log, and it will give you the same answer. So you will get the x is approximately 2.2 A756. All right. So be careful when they say the exact solution. That means you just leave it what it is. Okay. So now let's take a look at the second one here. I want to solve the equation, the a times e to the 2x equal to the 20. Okay, so the first thing here, I say, okay, I isolated the expression to one side. So what I can do here, I can divide by 8, divided by 8, both sides. So I have e to the what? 2x is equal to 20 divided by 8, 20 divided by 8. So what is that? It's 5 over 2, right? So it's 5 over 2. Okay, so now I need to sort of remember the second step is to take a log. So in here, since my base is e, so what type of log, I'm going to take here? I'm going to take a what? I'm going to take a natural log, right? Because the natural log and the exponential, they cancel each other out. So I will take the ln both sides here, right? Okay. So when you take the ln both sides, then here, this one will be what? ln e, the 2x, and the ln 5 over 2. Okay, so now you can do is you can, the ln, L and the e. So basically what happens here, we know they kind of like enemies, right? So they kind of cancel each other out. So this makes the problem a lot easier. So the 2x is equal to what? Natural log of 5 over 2, correct? Okay, so the natural log of 5 over 2, then the x will just be equal to the 2, the natural log of 5 over 2 here. And you can leave this is, or you plug it into the calculator. Okay, so if you're using the calculator, you will get x approximately to the 0.458. Okay, so this is by calculator. Okay, so if the problem said exact solution, then this is the what? This is what we call is exact solutions, right? Okay. All right, so it's pretty cool, right? It's easy. Okay, now let's take a look. The next one's here. This one, all right, so this one here is a little bit more complicated. Now, they have the e to the 2x minus ex minus 6 here. So for this problem here, you know, you cannot just take the log, you know, both sides. So you cannot here. So you cannot say, hey, how about like I do this? I move the 6 to the other side. Then I will take a natural log here, right? So, but we know the natural log a minus b is not equal to natural log a minus natural log b. So for doing this is no help, right? So I know, I'm not going to do that. It's not helpful here, right? Okay, so now let's take a look at what I can do here. So you see here, I observe this is E2x and EX. Okay, so if I change this a little bit, I say this is EX to the square minus EX minus 6 equal to 0, right? And then you see here, so this is like if you treat the whole EX is a sum function, is a variable X here, then you can factor, right? So here you can say, okay, I can do like this factor, the EX and the EX factors here. So this is a 3, right? So I say -3, and then this is a +2. So that's what I say, you can treat this kind of like a sum like x here, right? So this is a sum like x here. So the whole thing is just change it to the x squared minus x minus 6. Then you know how to factor. Now when you factor, remember your x is ex, the red x is ex, right? Okay, so now after that, then you set equal to 0. If this is equal to 0, that means this number equal to 0, this number equal to 0. So the EX plus 2 equal to 0, and or EX minus 3 equal to 0. I know the EX plus, that means EX equal to -2. And then this is not true here. Why? Why is not true? It's because I know the EX, the range of the EX has to be greater than 0. Remember the graph of EX is go like this. It's always above the 0, so cannot be -2. Okay, so now let's take a look at this one here. Now we simplify this problem to the EX equal to 3. Now I can take the natural log, both sides here is a natural log 3. That's good, because natural log and the e, they cancel each other out. So what I have here, I have x equal to the natural log of what? Natural log of 3, right? So this is my exact solution. All right, let's see the next ones here. How do I do this ones here? Okay, so when we try to do this one, looks like I have an x squared, ex. Well, maybe I can do here. I can do a factor. So I can take the x and the ex out, because the x and the ex, they are the common factor for both sides, right? So I can get the x and the ex out. So what is the first term have is 3. And what the second term left is x. That's good. So I have the 3 things, right? I have x times EX and times what? Times 3 plus X equal to 0. So I can set this equal to 0, this equal to 0, and this equal to 0, right? And solve it. Okay, so let's see here. I said X equal to 0. Okay, so that's nothing to solve. This is 1. Then I will set EX equal to 0. Okay, so what is X? No solutions, right? Why is no solution? Remember, the EX is to have asymptotes, right? This is the EX. It will never touch the 0, so it's a no solution. And then the next one's here. We have 3 plus X equal to 0. Now what is X? X is equal to the negative 3. So I have two answers here. X equal to 0 and X equal to negative 3. Okay, so this is kind of like how to solve the exponential function and by combining a little bit with the quadratic form factor. So it's very, very interesting problem. Okay, so now let's take a look, what is the log equations here, right? Okay, so let's take a look at a log equations, right? So logarithm equations. So a logarithmic equation is the one in which a logarithm logarithmic of the variables occurs. Okay, just like the exponential. So if you have log equations, it's the same ideas here, right? So if you have log and a, x equal to log a, y, okay? Okay, so log a and log a y. Hey, take a look here. Both of them have the same base. If both of them have the same base, then we can solve it quite easily. We say, hey, the x equal to y, see here, right? Okay, so just like exponential, if they have the same base, you can just remove that, and then you set x equal to y. So let's take a look for the example like this one here. So how do we solve here? So first take a look here. This is log, log, log. They do not have a base. What's that mean? They don't have a base. That means all of them. What type of log here? They are common log, right? Because they don't have a base here. Okay, so now I cannot just look at the equation here. This is log ax equal to log ay. I cannot just cancel log to the x squared plus 1 equal to x minus 2 plus x minus 3. I cannot do that because the log equation is only occurred, if you have log versus log here, right? Okay, so the first things here I need to do here is I need to combine to just have one log on the right hand side and one log on the left hand side. So you still remember the law of logs. If you have a log plus log, what happens here? You times it, right? So it's x minus 2, x plus 3. Now, both of them, you have a log 10s, right? This is log. Now, can I cancel that? Yes, I can remove that. Then I will have here, this is x squared plus 1 is equal to the x minus 2, x plus 3. So what is x minus 2, x plus 3 here? This is x squared plus x minus 6. All right. Okay, so now what we can do here is x squared, both sides. So pretty good. Then I move the 6 over, so I can get x equal to what? Equal to 7 here. All right. So when you do log functions here, after you solve it, right, you need to make sure to check solution is feasible That means it doesn't violate anything. Because log, we know everything inside the log here, right, has to be positive, cannot be 0 or negative. So when you plug in the 7, so for this one here, when you plug in the 7 to here, every one of them going to be positive. So you are okay. So this solution is okay here. Okay. Okay, so now let's take a look at what is the general guidelines here. So then we can use the example number 7 and try to show how to work on the general guidelines here, right? So here, let's see. Okay, so the general guideline number 1 here still is what? Isolate, just like we do the exponentials here. Isolate the logarithm function the logarithmic term on one side of the equation. All right. Okay, so let's take a look. Problem 8. Natural log x equal to 8. Oh, I already did number 1. Is natural log is on the one side. All right. Then next one's here. It's kind of like a backward, like the self-exponential, right? So we write the equation in the what? In the exponential form. Okay. Okay, let's take a look at what I mean. The step number 2 here. The natural log x, right? So remember, natural log x is just log x, log with the base e, x equal to 8, right? So the problem is say, hey, right now, write this term into exponential. So remember the log and the exponential exchange forms, right? So that means, do you remember here we said y equal to like a log x y, that means x equal to a to the y, right? This is what we did when we start the section 4.3. We said this is how we define the logarithm functions here. Okay, so now we change this to the exponential form. So that means e the x equal to what? Equal to the 8. No, I'm sorry. E the 8, right? So e the 8 equal to what? Equal to x. And that is our solutions here. Okay, now let's take a look at the second one here, right? The part B here. The part B is said log 2 25 minus x equal to 3. All right, so here this is my base. So I change this to the exponential way. So what is that? That is 25 minus x equal to 2 to the what? Third power. So that means this is 25 minus x equal to 8. Okay, so I plus x both sides. So I have 25 equal to the 8 plus x minus 8 minus 8. So I'm having the x equal to what? X equal to 17 here, right? Okay, so then, like we said, we need to check to see x17 is reasonable or not. So if you put this is 17, 25 minus 17, this is 8, so it's greater than 0. So we say this is okay, right? So this solution is okay here. So make sure, for the log function, you always need to check back because I know the log inside the log cannot have a negative number. All right, let's take a look at number 8 here. So let's do okay, so solve the equations. All right. So the first things here, they said isolated. Okay, so I can minus 4 minus 4. All right. So I have 3 log 2x is equal to what? Equal to 12, right? Okay. And then in order to put it into the exponential form, I cannot have this 3 in front. So what I need to do here, well, let's just divide that out. So you divide the 3 both sides. So here you got a log 2x equal to 4. Okay, the next thing you notice, this log function does not have a base. So we know if they do not have a base, what type of a log here? This is a common log, right? If this is a common log, and then what you do here, if this is the common log, and then this log is the basis of what? It's a tens, right? You can write here is 2x equal to 4. Then I can change that. So it's 2x equal to 10 to the what? 10 to the 4th, right? So 10 to the 4th is 1, 2, 3, 4. So then divided by 2, divided by 2. So what is my x here? X is 5,000, right? Okay, so the 5,000, you check back to see your equations. Oh yeah, it's positive. So this is okay. So this will be a solution here. Okay, now the number 9 here. Okay, so for this problem here, in fact, it say, you know, for this problem here, in fact, it wants you to solve it by using the graph. Okay, so I'm going to show you how to use your TI-84 calculator to solve these problems here, right? So you have x squared minus equal to 2 natural log x here. So you graph here. You graph in the calculator by setting y is equal to x squared minus 2 natural log x plus 2, right? So basically you have this is x squared equal to the 2, the natural log x plus 2, right? So you move this one over. So this is x squared minus 2, the natural log x plus 2 is equal to 0. So now that's why you say, okay, I'm setting this one equal to y. So you graph these ones here, right? Then you find out where the y touch zeros here. Okay, so put it into your calculator, right? So you put it into your calculator and you do the graph, and the calculator will give you a graph, something like similar like this. Okay, so we'll give you a graph similar, something like this, all right? And so we know you are looking for, because this is set equal to 0, right? So that means you find where is this 2 touch the 0. Then you move the cursor for your calculator to find what is this number. So you find out that this number is about 0.71, negative 0.71. And then this number is about the positive 1.6. So you plug in both here, it was fine. So the x is the solution is negative 0.71 or x equal to the 1.6. This is how do you use the graphing calculator to help you to solve. Sometimes the equation get more complicated, okay? All right, so now the last problem we're going to take a look here is how do I do the application problem, okay? So the number 10 here, we talk about the, you know, the exponential functions heavily used in the compound interest calculations, right? So let's say a sum of 5,000, okay, so $5,000 is invested in an interest rate is 5% per year. Okay, so let's write this out. So 5 is my principal, this is R. Find the time required for the money to double if interest is compounding according to these methods here, right? So remember the interest here, if compounding a certain period, so do you still remember what is the interest rate? What did we say is P, then 1 plus what? R to the N. then what here? NTs, right? Okay, so now in here, I know the P is equal to 5,000. They want it to double. That means what is my future value here? Is 10,000, right? So I invest the 5,000 here, and then it's 1 plus the R is equal to what? 0.05, right? And you try to so you try to compound semi-annually. So that means every year, how many times I compounding? Twice, right? So n is equal to 2. Okay, so now this is 2t. So basically, I'm going to solve this exponential equations, right? Okay, so let's try to do here. So first, I need to isolate this. So I divide by 5,000, both sides. So this is 2 is equal to 1 plus 0.05 divided by 2 is 1.025 and 2 t's, right? Then what I need to do here, take log, right? So we say log 2 is equal to log 1.025, the 2t. So you can move the 2t in the front by the law of logs, right? 1.025. So how many years here? So I can get a t is equal to the 2 log 1.025 and the log what? And the log 2 here, right? So then plug into your calculator and you will get a t is about 14.04. That means about 14 years. So about 14 years, and then your money double, right? So your money double if they compound semi-annually, right? Okay, so make sure you remember the formulas, right? Okay, so now the next things here, let's say, how about if I compound continuously? So if you compound continuously, let's write the let's write the, the formula, right? So what is the formula? Do you remember? We call it PERT, right? P-E-R-T, right? So the same things here. So be careful the different formulas, right? If it's a compounding continuously, what is the formula? Compounding certain period, what is the formula, right? Okay, so here still is a double, so it's 10,000 is equal to the 5,000 and the E 0.05 and the T is here. All right, so divided by 5,000, both sides. So I will get a 2 is equal to the E, the 0.05t. So what I need to do is here, I take a natural log of both sides, right? Because here, because here is E, so of course it's more convenient for me to take natural log. So I will take a natural log of 2 is equal to the natural log of E, 0.05t. Natural log and E cancels, right? So I got a natural log of 2 is equal to the 0.05t. So what is the t's here? Is 0.05 natural log of 2. Then you put it into the calculator, so it will be 13.86 years. So as you see, we know the more you're compounding, the more frequency you're compounding, you get more interest, right? So that's why you can reach your goal faster. So for compounding, if you're compounding continuously, you only take 13.86 years. And if you're compounding, semi-annually, right, you take the 14.04 years. So this one is a little bit shorter than this one, right? Like we know about the interest. Okay, that's it. And that is the end of this sections here. And we learned how to solve the exponential and the logarithm functions, right? So remember, for the solve the exponential, you want to take the log of both sides, solve the logarithm. So the one easy way is to change it to the exponential, right? And then solve for x here. All right, that's it. And I hope you enjoyed this chapter. And like I said, chapter 4, the exponential and the logarithm function is a super, super important chapter, and which, in the calculus, the both functions play a very, very important roles in the calculus. Okay, that's it. And hope you got a pretty good understanding about these two functions here. All right, and you have a good day, and talk to you later for our next chapter here. All right, bye.